everyone. Hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, after talking about the first come first serve algorithm, we are going to move ahead and talk about shortest seek time first algorithm. Okay. So SSTF stands for shortest seek time first. Now, this algorithm basically selects the request with the minimum seek time from the current head position. So, if let's say the current head is 50 and there is a request which is giving a seek time of 30 and one is giving a seek time of 80. So, the one which is giving a minimum seek time will be the request which will be processed first. Okay. Now, since the seek time increases with the number of cylinders that are being traversed by the head, that is why shortest seek time first basically chooses from the pending request where to the position where the current head position is. Okay, so it's like request having the shortest seek time are executed first. Okay, so what we do is we actually calculate the seek time of every request in advance in the queue. Okay, and then in the queue only, since we have calculated the seek time, we basically schedule the request according to their seek time itself. Okay, that is why the request which is nearer to the disk arm, right, that is going to be executed first. Okay, now understand that shortest seek time first algorithm is definitely a improvement above first come first serve. Okay, as it tries to decrease the overall average response time as well as the I would say seek time, and tries to increase the overall throughput for the system. Okay, let's understand this with the help of an example. So we have 98, 183, and over here we have 37, 120, and 122, 14, 124, 67, and 65 and 67. And currently the head of the cylinder, head pointer is basically in cylinder 53. Okay, so here it is at 53, right? Now what basically happens is it checks. Now it's currently at 53. Now out of these, it will pick the request 65. Okay, because from 53, the nearest request that can be processed is 65. From that, the nearest one that can be processed is 67. After processing 67, it has two options. Either it can go to 37 or it can go to 98. Okay, if it goes to 37, the seek time is 30. But if it goes to 98, the seek time is 31. That is why it goes to 37. From 37, the nearer one is 14, right? And from 14, we go all the way back to 98, and then 122, 124, and 183. Okay, so this is how we basically process request in shortest seek time first. We calculate the seek time of every request in advance based on the head arm, and based on that we take the call which request needs to be processed in which particular order. And this way we try to decrease the average response time and the seek time and try to increase the overall throughput. Let's take another example also together and understand this. Okay, so what I'm going to do is, and I'm going to actually consider the same request for better understanding. I'm not sure if it will get copied. No worries, let's draw it itself. So here we have shortest seek time first, okay, where the requests are same as the previous one, which is 82, 170, 43, 140, 24, 16, and 190. Let me confirm as well. Perfect. And then the head is basically at 30. Here early, okay, head is at 50 only because we want to keep it same. And here we have this. We have 0, 16, 24, 43, 50, 82, 100, 140, 150, 170, 190 and 199. Okay. Now what happens over here is we'll process the request. We start at 50, okay, and we basically try to first process the request over here, which is for 43. So we process 43 first. This is done. Then we try to process the request 24. So we process this. Then we try to process 16. So we go here. From 16, we go back all the way to 82. So we go here. Then we go all the way to 140. Then we go all the way to 170 and then 190. Okay. So this is how basically I would say the shortest seek time first works. And what will be the total seek time? It will be 50 minus 43 plus 43 minus 24 plus 24 minus 16 plus 82 minus 16 plus 140 minus 82 plus 170 minus 140 plus 190 minus 170, and this total will come out to be a value of 208. Now compare the previous answer. It was 642 and now what did you get? 208. Definitely a very, very big improvement over the previous algorithm. Okay. So that is why when we talk about the advantages and the disadvantages of this technique, we say that here the average response time, right, on an average how much time it takes, it decreases considerably over here. Okay. The next thing is that because of that, the overall throughput of the system increases. Okay. And whenever we talk about the disadvantages of using this approach, okay, here first of all, there is an overhead to calculate seek time over here, because whenever you will have a arm at a particular position, you will have to calculate the seek time in advance. Okay. Secondly, what happened is it can actually cause starvation. Okay. Because if a request has a higher seek time as compared to incoming request, so it can cause starvation if a particular request has a higher seek time always compared to incoming requests. Okay. And the third is that I think, yeah, this much mostly would be the points related to shortest seek time first algorithm. Okay. I hope this is clear to everyone. We've taken another example as well for you to kind of understand if there was any doubt in the previous example. Okay. Perfect. So this completes our discussion for shortest seek time first scheduling. Now, next what we can do is we can move ahead and talk about the scan scheduling. Okay. So what happens is in scan algorithm, the disk arm actually starts at the end of the disk. Okay. And it basically starts from this end and it tries to move towards the other end. Okay. Servicing request as it reaches each cylinder, right, until it gets to the other end of the disk. Okay. And at the other end, what we do is that the direction of the head movement is reversed. Okay. So let's say you keep processing request and you reach to the end, right? Then you will go back again. Your direction will be reversed. So if you were going here, now you will start going here. Okay. And the head continuously moves back and forth like this across the disk. Okay, let's take an example itself and that will give you all the clarity that you require. So in scan, what happens is the disk moves into a particular direction and whatever request comes in that direction, it services those incoming requests which comes in its path. Okay, and after reaching to the very end of the disk, it reverses its direction and starts servicing the requests which are in the path of the other direction. Okay, so this algorithm works kind of like an elevator. Okay, that's why this is also known as a elevator algorithm. Okay, so here let's say these are the requests 98, 183, 37, 122 and all, and the head is at 53. Now here let's say I first decide to move towards the left. So what are all the requests towards the left? 37, 14, 0. And then when I have reached to one end, now I will go start moving in the other direction. I will go to 65, 67, 98, 122, 124 and this. Okay, so you can decide any direction you want to start with. You can either take up the left direction or you can take up the right direction, and based on that you keep processing requests in that direction till you move or reach to the end of the disk. And after you have moved to the end of the disk, then only you can start ahead and go ahead and take the other direction, and then keep processing requests in that direction. Okay, so that's how the overall idea for a scan scheduling kind of work. It's more or less like scanning, like you're moving to the end, then you're coming back, and then you move back and change the direction. Okay, let's this was another example, but let's also take that same example again as well, so that we can compare the answers and the response time in all of these scenarios. So in scan, the request will be the same. I'm not able to copy, so I'll write it down again, which was 82, 170, 43, 140, 24, 16 and 190. Okay, and here initially let's say the head is at 50, but initially the head is at 50 and we will start moving towards a direction. And Hamesha, what we also know sometimes is that the disk arm, let's say, should move towards larger value. Should move larger value. Okay, let's take an example. $43.50. $150. This. Okay. So what do is we start, and here we have to move towards the largest value first. You can choose the other one also, or if it is given, then you can choose that one. So from 50, we go to 82. From 82, we move towards 140. Okay. And then from that, we move towards 170. And from that, we move towards 190. And then we go to the very end as well. Okay. This is the end. So this is also taken care of. Then we go directly to 43. Okay. Then we are going to 24 and then we are going to 60. Okay. So this is the order in which the request will be processed. So what will be the total seek time over here? It's actually very simple to calculate over here, because one time you are going from 50 to 199. So the seek time is 199 minus 50 plus, right? You are going from 199 to 24 and processing request and path. So the total seek time over here comes out to be 332, which is larger than the seek time which we had in shortest seek time first algorithm. Okay, so not very large, but yeah, slightly greater. So what are the few advantages of using this kind of an approach? Okay, that in this also, usually the throughput is very high. Okay, and here it also has a good average response time, also far better compared to first come first serve. Okay, but some of the disadvantages, or like I would say the only disadvantage that comes to my mind right now, is that there is a long time waiting for request, okay, for locations that is just visited by the disk arm. Okay, so sometimes what happen is that there is a long time waiting for the request, okay, just visited by the disk arm. Okay, let's say here you basically were at the request 82, okay, and now let's say another request comes for 56. Now the request which just came, okay, which was very close to the disk arm, now if a new request 56 comes, it will actually take a lot of time to process the request. Okay, so the locations which have just been processed, if any other new request comes, okay, which are just for the positions either just visited by the disk arm, it takes a lot of time for them to get processed. Okay, so that is what one of the disadvantage is for using the scan algorithm. All right, so I hope both the algorithms are clear to everyone. We discussed two algorithms in this video. We talked about the shortest seek time first, where we calculate the seek time for every request in advance and basically schedule those requests based on starting from the shortest seek time to the longest seek time. The next one that we have over here is basically scan scheduling. Okay, so what do we do in scan scheduling is we basically scan the disk starting from head to go to the one end, then the other end, and then back end. So it kind of moves like this, okay, and it kind of reads the incoming request on that particular order. All right, so far what we've seen is that the shortest seek time first algorithm was actually the fastest. Okay, so let's take a look at the last two algorithms as well, which we have, and then we'll have a better clarity and a bigger picture on what exactly all these algorithms are. All right, so let's move ahead.